Welcome back to the deep dive. This is the place where we take on these complex, sometimes confusing topics, we filter out all the noise, and we try to deliver the concentrated truth.
And today, we are tackling something it's just so fundamental to building quality software.
It really is.
Mm.
But it kind of operates in the shadows, doesn't it? It gets
Yeah.
overshadowed by the excitement of actually running the code and seeing things happen.
Exactly.
You send us your source material, and you've really zeroed in on this foundational concept in quality assurance. So our mission today is to just crack it wide open. Static testing.
That's right. And if you think about dynamic testing, it's like stress testing a finished building by having a bunch of people jump up and down on the floors.
Right.
Static testing is the intellectual work, the rigor you apply long before the first shovel even hits the dirt.
I like that analogy.
And the source material we're using, the ISTQB Certified Tester Foundation Level Syllabus version 4.0.1, it gives this a whole chapter, chapter 3, and it gets to the core dilemma every single project faces, which is that waiting until the software is actually running to find your problems it's just incredibly expensive, it's time-consuming, and the risk just goes up and up.
Absolutely. Let's stick with that building analogy for a second because I think it works really well. Imagine you're building a huge skyscraper.
Okay.
If you wait until you're building the very last floor to find out that the blueprint, the system architecture document,
Oh.
had a major flaw in its load-bearing calculations.
Oh, that's catastrophic.
It's a disaster. You are tearing down so much concrete, so much time, so much budget. So our mission today isn't just to define static testing. We need to unpack the how, the mechanics of reviewing those critical blueprints.
Yeah, and we need to separate it from that common idea of testing, which is, just running the code.
Exactly.
Yeah.
And then we'll get into the structured process of doing reviews, both formal and informal, that basically save you time, money, and, let's be honest, sanity.
A lot of sanity.
By pushing that defect detection way, way earlier in the life cycle. So this deep dive is your shortcut to mastering defect prevention, not just detection.
That's the key word right there, prevention.
Okay, let's start with the absolute basics. We keep saying before the code runs. Can you just give us this simple, definitive definition of static testing? And then maybe we can unpack what that really implies.
Sure. Defined as simply as possible, static testing is the evaluation of work products without executing the software.
Okay, so no running anything.
No running anything. You're analyzing the artifact itself. That could be the requirements document, a design file, the source code text, just the text file. You're looking at it without ever compiling it or running it.
So it's completely different from dynamic testing, which,
Yeah.
well, it's in the name. It requires execution, it needs memory, it needs processing time.
Correct. So on the face of it, it sounds like it's a purely intellectual exercise, right? Reading, checking, thinking.
Yeah, but you mentioned tools earlier. How do tools fit into this idea of not executing anything?
That's a great question because it's really a mix of both. It's intellectual analysis and automated help, and you kind of need both. There are two main ways we do static testing. First, and this is what we're really going to focus on today, is what we call manual examination. That covers all the different kinds of reviews, inspections, walkthroughs, the human element.
Right, using our brains and our experience.
Exactly. Leveraging that human expertise and critical thinking. But the second way is tool assistance, which most people just call static analysis.
Okay, so what are these tools actually doing if they're not running the code?
They're designed to scan the source code, or in some cases, other documents, to check for very specific characteristics without running a single line. Think about when your compiler warns you about an unused variable.
Okay.
That's a form of static analysis. Or tools that specifically hunt for security vulnerabilities, what we call SAS tools, static application security testing.
Right, they're reading the code for patterns that look like known vulnerabilities.
Yeah, exactly. Even a really good spell checker or a readability index tool that you run on a user manual. Technically, that falls under the static testing umbrella.
That's a great point. So we're moving way beyond just finding bugs in code that runs. We're looking at the fundamental quality of everything we create.
Yes, the artifacts themselves.
Let's drill down on those static analysis tools for a minute, because they're a huge part of modern development, right? In continuous integration pipelines and so on. What can they find that a human or even dynamic testing might just completely miss?
This is really where they shine, especially in these huge, complex code bases we have today. You can break down what they do into Two main kinds of structural checks: control flow analysis and data flow
I can
analysis.
take those one at a time. Control flow.
Control flow analysis is all about mapping every possible path that the execution could take if it were running. So a tool might find something like unreachable code,
Right.
a section of logic that, because of a bad conditional or some weird branching, can never, ever be executed. There's no path to it.
And a human might just skim past that, buried in thousands of lines of code.
Easily. And dynamic testing will definitely not find it unless you just happen to write a test for a path that doesn't exist. Unreachable code is just. It's bloat, it's a maintenance risk, it's needless complexity.
Okay, so that's control flow. What about data flow analysis?
Data flow analysis is all about the data itself, the variables. It tracks how they're initialized, how they're used, how they're changed throughout the program.
Give me a classic example.
The classic one is finding a variable that is used before it has been initialized.
Right. That can cause some really weird, unpredictable bugs.
Exactly. If you run that code dynamically, the failure depends entirely on whatever garbage value happened to be sitting in that memory location at that exact moment. It's an erratic, impossible to reproduce bug.
But static analysis sees it immediately.
Instantly.
Huh.
It flags it as a fundamental programming error, clean and simple.
So these tools are really enforcing design and logic principles that dynamic testing can only ever hint at after a crash or some other weird behavior.
That's a great way to put it.
This brings us to the bigger question of scope. What kinds of things, what work products, can we actually apply this static scrutiny to? You mentioned it's not just code.
No, and that is such a key point. Virtually any work product created during the entire development process is fair game. And this is powerful because it lets us find defects long before they ever get baked into the code.
And what are we talking about?
We're talking about source code, for sure, but also the really critical early documents like process specifications, system architecture
It's
specifications,
user stories.
requirements.
Absolutely. User stories requirements, high-level design documents, anything. And the objective of static testing goes way beyond just finding bugs.
Right.
It's evaluating these critical quality characteristics of the artifacts. Things like readability. Is this design actually clear? Completeness. Have we covered every single requirement? Correctness. Is the logic in this document sound?
And testability, that's a big one. Can we even write tests for this thing easily? Huge. And consistency. Do the user stories actually match the acceptance criteria? It's all about the quality of the artifacts themselves.
Now, you just touched on two really important and often confused technical concepts: verification and validation. How does static testing help with both of those at the same time?
This distinction is so crucial, and static testing is the ultimate tool for getting them both right early on. It serves two goals. First, verification.
Okay.
Verification checks if the system or the work product meets its specified requirements. So going back to our blueprint analogy, verification asks, does the plumbing installation in these construction drawings match the requirements in the specification document for a high-pressure system?
So you're checking one document against another for consistency.
Precisely. You're verifying consistency between two artifacts. But then there's validation, and this is much deeper.
How so?
Validation checks if the requirements themselves are correct. Do they align with what the user actually needs and what the stakeholders expect in the real world? It's asking the big question, are we building the right product?
I see. So our static review might verify that the requirements doc is complete.
Right, everything's there.
But validation asks if the user actually needs a high-pressure plumbing system in the first place, or if that whole idea was based on a faulty assumption at the very beginning.
You've got it. And by bringing all the stakeholders into that review process, static testing makes sure we are building the right thing correctly, not just building a thing correctly.
Which brings us to the part that every project manager and business leader listening is waiting for. This is where the rubber meets the road. We know testing is vital, but how does static testing specifically give us a measurable benefit in cost and efficiency?
It's the most direct implementation of a foundational principle of all testing. Early testing saves time and money. And that's not a philosophy, it's an economic reality. It's been proven over and over for decades in software development.
So what's the principle?
The principle is that defects you find and remove early, say, in the first draft of a requirements document or a design spec, cannot cause more defects later on. They can't ripple downstream into the code, into the automated tests, into the deployment scripts.
And it's that ripple effect that drives up the cost curve, right?
Exactly. Think about it. When you catch a human error in the requirements phase, the cost to fix that defect might be, let's call it 1 unit of effort.
Okay, 1 unit.
If you don't find that same defect until, say, integration testing, the cost might be 10 units. If you find it just before release, or worse, the customer finds it in production.
Oh, that's the nightmare scenario.
Right. The cost can easily be 100 units or more. It's an exponential curve.
And why is it so much more expensive later?
Because to fix it then, you have to go all the way back. You have to find the original flaw in the requirement, update the design, refactor the code, update all the documentation, update all the tests that were built on the faulty assumption, deploy a fix, maybe issue an emergency patch. The effort is just vastly greater, not to mention the damage to your reputation.
So static testing isn't just a cleanup operation. It's proactive. It's preventative.
Yeah.
It's like quality assurance's silver bullet for cutting costs.
Precisely. And it offers unique value that dynamic testing just can't. First, you have the obvious benefit of early detection. The review process can start the moment a document is drafted, long before any code is even executable.
So you're finding problems at their source.
Yes. Second, it's brilliant at finding what we can call hidden defects, things dynamic testing might never see. We already talked about unreachable code and data flow issues, but think about flaws in design patterns or logical loops or inconsistencies between two different parts of an architecture document.
Right, because dynamic testing is limited by the actual test data you feed it and the code paths you happen to execute.
Exactly. If a critical code path only gets hit 1% of the time in the real world, your dynamic test might miss the bug in it for months, maybe years. A human reviewer or a static analysis tool spots the logical flaw on paper regardless of how often it would run.
That distinction is so important. Dynamic testing only finds a defect if you happen to run the one specific scenario that triggers the failure. You have to feed it the right data under the right conditions.
Yes, and beyond that, static testing, especially through the review process, builds a shared understanding across all the stakeholders.
How does that work?
Well, when you get developers, testers, and business reps all in a room reviewing the same document, you're not just finding flaws, you're verifying the requirements together. You're building confidence because everyone has seen and agreed on the blueprint.
So it prevents that classic project problem where the developers build one thing, but the business wanted something slightly different.
It prevents that costly rework that comes from misunderstandings and misaligned visions. It really reduces what you could call the organizational drag coefficient. A project can be technically perfect, but if it doesn't meet the needs of the business, it's a failure. Static testing forces that alignment early.
Now, we do have to admit, formal reviews take time, right? You're paying for the time of multiple, often highly skilled people.
You are. There's an upfront cost, no question. But the industry consensus is overwhelming. The overall project costs are almost always lower than if you skip reviews. The money you save by avoiding 1 or 2 catastrophic late-stage fixes far, far outweighs the initial investment in review time. It's an investment in process maturity.
Okay, so let's really nail this down. Let's compare static and dynamic testing side by side. They are complementary, right? Static testing doesn't replace dynamic testing.
Not at all. You absolutely need both.
So to be a true expert, you need to know where one begins and the other ends. If I had a whiteboard and I asked you to draw out the core differences, what would be the main pillars?
Okay, the first and most important one, the philosophical difference, is the discovery mechanism.
How they find things.
Right. Static testing finds defects directly. It does it by analyzing the work product itself. It's deductive. You scan a document and you say, there's a logical flaw right here in this design.
Okay, direct discovery. What about dynamic?
Dynamic testing causes failures. It runs faulty code, which produces a failure, and then you have to do more analysis to find the underlying defect that caused it. It says, the system just gave me an error code. Now I have to go on a bug hunt to find out why.
So the defect is inferred from the behavior?
Exactly. Static tells you, here is a defect on line 50 of the requirements document, while dynamic says, the foundation just cracked when I stood on it.
That's a perfect way to put it. Static testing breaks that cause and effect chain much, much earlier.
It does. The second big distinction is reach.
Reach.
Yeah, how much of the product it can examine. Static testing can easily find defects in code paths that are very rarely executed or are just structurally hard to get to with dynamic tests. Think about a complex error handler for a very specific, rare set of conditions.
Right, trying to simulate that in a test environment could be a huge pain.
Or impossible. But a static analysis tool can spot a flaw in that logic just by reading the code's structure. It guarantees a deeper quality analysis, even if you never manage to hit that path in your test lab.
Okay, that makes sense. What's the third pillar?
Applicability. What can you actually use these techniques on? Static testing works on non-executable work products, documents, designs, specifications, models.
The blueprints.
The blueprints. Dynamic testing, on the other hand, absolutely requires an executable work product and an environment to run it in. You can't run a performance test on a Word document.
But you can review that Word document for ambiguities, for contradictions, for things that are missing.
Exactly. That's why it's so vital for that upstream quality control.
And the final pillar.
The final one is metrics. The things they measure are fundamentally different, and it all comes down to whether you need to execute the code.
So what does static testing measure?
Static testing measures quality characteristics that are not dependent on execution. Things like maintainability. How easy is this code to change? Security, does this code follow known secure patterns? Design consistency, these are all structural qualities.
And dynamic testing measures.
Things that are dependent on execution. Performance efficiency, how fast does it run under load? Reliability, how often does it crash? Usability.
So they're really two sides of the same quality coin. Static testing is making sure the building's structure and materials are correct on paper.
Yes.
And dynamic testing is making sure the building actually holds up when you subject it to real-world weather and people walking around inside.
You just have to have both.
You absolutely have to have both.
This moves us perfectly into the most human part of static testing, the review process, both formal and informal. Before we get into the structured steps, let's talk about the philosophy. Why is this early, frequent feedback so critical for a project's success? Isn't just writing good code enough?
Oh, code is never enough. And that's because software development is, at its heart, a communication process. We're translating human needs into machine instructions.
That's a great way to think about it. And having these robust, early, frequent feedback loops is critical because they stop the compounding cost of misunderstanding. They let you communicate potential quality problems early so you don't end up in a situation where the product you built doesn't meet the stakeholders' original vision.
Or, maybe even more importantly, their current vision. Things change.
That's a key point. Visions evolve. That failure to meet the vision is the recipe for that costly rework we talked about, but it's also, just a recipe for organizational tension.
I can imagine.
It is. The cost of rework is the part you can measure, but the lack of stakeholder involvement leads to damaged trust, missed deadlines, a hit to team morale. Frequent feedback ensures that requirements changes, which are basically inevitable on any real project, are understood and implemented sooner.
So it's a core part of that shift-left idea we hear about so much.
It's the absolute core of it. You're identifying problems in the test basis, the requirements, the designs, and you're fixing them immediately.
So reviews aren't just about hunting for defects. They're about communication and managing risk.
Precisely. They make sure the development team is focusing its effort on the features that actually deliver the most value and that they're mitigating the risks that have been identified.
Can you give me an example of that?
Sure. Let's say a reviewer points out that a user story is missing any acceptance criteria related to data privacy.
A big deal these days.
A huge deal. That feedback lets the team immediately focus on closing that compliance risk instead of finding the vulnerability during a last-minute security audit before release. It just fosters better cooperation and transparency between dev, testing, and the business side. Everyone starts to own the quality because everyone had a hand in validating the blueprint.
Okay, so we're all sold on the idea that feedback is crucial. But how do we organize it? How do we make it structured and productive so it actually gives us measurable results and isn't just another, casual meeting that goes nowhere?
Right, avoiding the meeting that could have been an email.
Yeah, exactly. The ISO/IS 2020-46 standard gives us a framework for this, a structured process. Could you walk us through the 5 core activities? And I think it's important to stress that you can tailor the formality, but these basic steps are always there.
Absolutely. The structure is what makes it work. Even in a very informal review, having these steps as a mental checklist just ensures you're being thorough. And another key point, for a really big, complex work product like a massive architecture document, you might invoke this five-step process multiple times on smaller, more manageable chunks.
Ah, that addresses a common complaint, right? That trying to review a 300-page requirements doc in one sitting is just impossible.
It's a recipe for burnout. Your effectiveness at finding defects would drop to near zero after the first hour. You have to respect the reviewer's cognitive load.
Okay, so what's the first activity?
The first one is planning, and this is probably the most underrated step of the whole process.
Why do you say that?
Because this is where you define the entire scope of the review. You detail the purpose of the review. Are we here to validate technical feasibility, or are we checking for regulatory compliance? Those are very different goals. You define the specific work products, the quality characteristics you're looking for, and most critically, you set the exit criteria.
The exit criteria.
Yep.
That's basically the definition of done, right? What makes for good exit criteria?
Good exit criteria are measurable and objective. It can't be when it feels right. It has to be something like, no priority 1 or 2 defects remain open. Or maybe the work product has a maximum of 0.5 defects per page.
That's very specific.
It has to be. Or all acceptance criteria have been deemed complete and unambiguous by at least 90% of the reviewers. In the planning phase, you also schedule the effort and make sure enough time is set aside for both preparation and the review meeting itself.
Okay, so planning sets the stage.
Right.
Then we move into preparing for the review.
That's the second activity, review initiation. The goal here is just readiness and alignment. You make sure every participant has access to the latest version of the work product. You make sure they understand their specific roles and responsibilities, which we'll get into next.
And any supporting documents, I assume?
Yes, exactly. Any checklists or standards they're supposed to be checking against, you're basically ensuring operational readiness before anyone starts the real work.
Then comes the main event, the individual work, which happens alone.
Activity 3, the individual review. This is the independent assessment. Each reviewer, on their own time, goes through the work product. They use specific techniques, maybe checklist-based reviewing or role-based reviewing, where one person looks at it as a security expert, another as a performance expert.
And what are they doing?
They are identifying and logging every single anomaly they find, and also any recommendations or questions they have. The key is they aren't waiting for the meeting to start discussing things. They are doing their homework thoroughly beforehand and logging every potential issue.
Okay, so now everyone's done their homework. They come together for the discussion. This seems like a critical moment where these anomalies might turn into actual defects, or they might not.
This is activity 4, communication and analysis. And you're right, this is where the real clarity comes from. It's usually a review meeting. All the anomalies that people logged individually are brought together and analyzed. And an anomaly is just that, a finding. It's something that deviates from what was expected. It could be a simple spelling mistake, a question, or a major inconsistency.
Can you walk me through a practical example? What's the real difference between an anomaly and a confirmed defect at this stage?
Sure, let's say a reviewer logs an anomaly. The requirement spec says the button color must be blue, but the design document says it must be azure.
Okay, a clear inconsistency.
It's an anomaly, but when it's discussed in the meeting, the team learns that azure is the specific color code in the company's UI style guide that corresponds to the general term blue.
Ah, so it's not really a defect.
Exactly. The anomaly is resolved as maybe a communication issue. The action might be to update the requirement stock, to use the more specific term. A true defect, on the other hand, is a confirmed flaw that will cause a failure or stop the requirements from being met.
And for those, you have to decide what to do.
For every anomaly that gets promoted to a defect, you have to decide its status, who owns it, which person or team is responsible, and what the required action is. Fix it, defer it, or maybe even reject it. This is also where the team decides if the work product as a whole is meeting those exit criteria we set back in the planning phase.
So this meeting is really about cutting through ambiguity and making sure everyone is working from the same set of facts.
Yes, it's a validation of the findings, and that leads to the final step, activity 5, fixing and reporting.
Closing the loop.
Closing the loop, you create formal defect reports for anything that needs action. The author of the work product then goes and fixes those defects. And once those predetermined exit criteria are finally met, the work product can be formally accepted. And the results of the review, the metrics, what you learned, are documented and communicated back to the team. That's how you improve the process for next time.
That structured process absolutely requires clear accountability. So who does what in a formal review? It sounds like it takes a pretty organized team, and knowing the roles has to be key to making it run smoothly.
Oh, clear, distinct roles are the foundation of a successful, unbiased review, especially for making sure the focus stays on the product and not on, the personality of the author.
Yeah.
The syllabus lays out 6 main roles, and each one has a very unique function.
Okay, let's go through them.
First, you have the manager. This person is responsible for providing the resources, the staff, the time, the money. They're the ones who decide what needs to be reviewed based on risk and business priorities. They provide the budget and the mandate.
Makes sense. Then the person who wrote the thing.
Right, the author. Their role is very straightforward. Create the work product, and then after the review, fix the defects that were found.
Okay, what about the person running the meeting?
That's the moderator, or you might call them the facilitator. And this is probably the most critical interpersonal role in the whole process. They make sure the meeting runs effectively, they manage the time, they mediate any disagreements.
And most importantly,
Most importantly, they ensure a safe review environment, an environment where everyone feels they can speak freely without worrying about personally attacking the author.
that safe environment piece feels really critical. I've seen reviews that just devolve into critiques of the person, not the document. How does a good moderator stop that from happening?
A skilled moderator is very active. They enforce time limits on discussions. They'll step in if the conversation turns personal. They constantly guide the group back to objective analysis of the anomalies. They might say something like, okay, let's table the discussion on the design choice itself and focus on how requirement R45 is written. Is it ambiguous? They depersonalize everything.
Got it. Okay, who's next?
Next is the scribe, or the recorder. This person's job is to collate all the anomalies that were identified and record everything that happens in the meeting, the decisions, any new issues that come up, the action items. Their accuracy is essential for good record keeping.
So the scribe is the record keeper, the moderator is the people manager. Who are the actual experts looking at the document?
Those are the reviewers. They are the ones performing that independent assessment during the individual review phase. They're your subject matter experts, maybe end users, other people from the project. Stakeholders who are responsible for checking the work product against whatever standards are important. They're the eyes and the specialized knowledge in the room.
Okay, that leaves one role.
The review leader. This person takes the overall responsibility for the administration of the review. They decide who needs to be involved, they schedule the when and the where, and they monitor the whole process to make sure it stays on track and that the exit criteria are eventually met.
Now that brings up a practical issue I see in a lot of organizations. The manager provides the resources, and the review leader organizes the process. In smaller teams, those two roles can often be the same person.
Very common.
How does that tension between the manager's goal, which is often schedule-driven, and the leader's goal, which is quality-driven, potentially mess up the process?
That overlap is a real systemic risk. If your manager is also your review leader, they might feel intense pressure to rush things to meet a deadline. They might be tempted to cut the time for the individual review phase, which is disastrous for quality.
Because their primary goals are in conflict?
Exactly. A manager's goal is often project completion. A review leader's goal is quality assurance. When they conflict, quality usually loses. And that's why in the most formal type of review and inspection, there are very strict rules that force certain roles to be separate people just to guarantee that objectivity. We'll get to that next.
Perfect. So now we can get into tailoring the process.
Yeah.
The syllabus outlines 4 main types of reviews, from super casual to, as you said, military-grade formal. This isn't just about picking one, it's about applying the right level of rigor for this situation. Why is it so important to have these different levels?
It's all about efficiency and managing risk. You don't want to use a sledgehammer to crack a nut. The level of formality you need is driven entirely by the context, the risk of the work product, how critical it is, how complex it is, any legal or regulatory rules.
So you wouldn't do a full formal inspection on a minor text change on a website.
Exactly. But you absolutely would for the system architecture of a medical device or a financial trading platform. You have to pick the right review type to get the job done without wasting everyone's time and money.
Okay, so let's start at the most casual end of the spectrum and work our way up.
That would be the informal review. These don't follow a defined process. There's usually no formal, documented output, no official report, no metrics, no sign-offs. They're fast, they're flexible, often just ad hoc.
So what's the point then?
The main objective is just immediate, simple anomaly detection. It's a developer asking a colleague to quickly look over a bit of code, or a writer asking someone to give a document a quick proofread. The value is speed and quick correction, but you get no traceability or data for process improvement.
Got it. Moving up one step in formality, we get to the walkthrough.
Right. The walkthrough is much more structured. The critical difference is that it is led by the author of the work product.
Ah, so the creator is the one presenting it.
Yes, the author walks the team through the document or the code, explaining their logic and design decisions, and the objectives are much broader here. Evaluate quality, yes, but also educate the reviewers, gain consensus, generate new ideas, motivate the author, and, of course, find anomalies.
That educational part sounds unique to the walkthrough. It's about knowledge transfer.
It is, and that's why doing that individual review preparation before the meeting is often optional for a walkthrough. The meeting is driven by the author's presentation, which guides everyone's understanding. It's really effective for getting everyone on the same page quickly.
But I could see a downside. If the author is leading, they might unconsciously, rush past the parts they're less confident about.
That's the primary risk. It can limit defect detection, which is why when the subject matter is really dense or technical and you need pure objectivity, you move up to a technical review.
Okay, so what defines a technical review?
Objectivity is the priority. These are led by a trained moderator, not the author, and they must be performed by technically qualified reviewers, usually subject matter experts.
So you're bringing in the big guns.
You are. The objectives are really focused. Gain consensus on technical problems, find anomalies, evaluate quality against technical standards, and just build confidence in the technical solution. They often use detailed checklists tailored to technical criteria like adherence to specific design patterns or performance constraints. It's formal, but it usually doesn't involve the super strict metric collection of the final level.
And that final level, the pinnacle of formality, is the inspection. If you need maximum rigor, this is the tool you use.
Absolutely. The inspection is the most formal, the most structured, and the most resource-intensive review type. It demands that you follow that complete 5-step generic review process we talked about to the letter. Detailed planning, define roles, tracking against exit criteria, everything.
And what's the one single goal of an inspection?
To find the maximum number of anomalies possible. That's it. It's a defect hunt. And it achieves that rigor through some very specific mechanics.
Such as?
First, the inspectors use defined reading techniques. They don't just skim it. They use checklists or specific role-based perspectives to make sure they cover everything systematically. Second, the process often includes reading rate monitoring.
Wait, what? They monitor how fast people are reading?
Yes. Research shows that if reviewers read too fast, their defect detection rate just falls off a cliff. So the inspection leader might actually set and monitor reading rates maybe 1 or 2 pages per hour for a really dense technical document to ensure a thorough pace.
That is an incredible detail. That really shows the level of seriousness. It's measuring the speed of thinking to ensure quality.
It really does. Third, inspections require you to collect and analyze specific metrics. Defects per page, time spent in each stage, the rate of discovery. This data is critical because you feed it back into your development process to improve the process itself. It's quality control on your quality control.
And you mentioned the roles are stricter here.
Yes. To guarantee that objectivity and remove any bias in an inspection, the author is explicitly forbidden from being the review leader or the scribe. The person who made the thing cannot be the one to organize the review or officially record the findings.
That progression is just fascinating. An informal review is a quick check. A walkthrough is about education and consensus. A technical review is peer-driven technical scrutiny. And an inspection is a full-scale, metrics-driven defect hunt. The choice you make completely changes the outcome and the effort required.
And it defines your risk mitigation strategy.
So if an organization decides to make this investment in structured reviews, and it is an investment of time and people, what are the key factors that determine if that investment actually pays off? What makes a review successful, beyond just finding a few typos?
The difference between a review being a really beneficial quality gate versus just another obligatory time-wasting meeting, it really comes down to preparation, the culture, and setting clear expectations. There are a few non-negotiable success factors.
Well, it's at the top of the list.
You have to define clear objectives and measurable exit criteria. If the team doesn't agree on why they are reviewing the document and what quality bar it has to meet, the whole thing is a waste of time. And the syllabus makes a critical point here. The evaluation of the participants should never, ever be an objective.
Right. It's about the product, not the people.
Exactly. Reviews are for improving the product and the process, not for grading the author or the reviewers.
And that feeds right back into creating that safe review environment you were
Yep.
talking about. If people feel like they're being judged, they're going to be defensive or they won't prepare properly.
Precisely. The second factor is to always choose the appropriate review type for the context. Don't use an informal review for a mission-critical system requirement. That's a guaranteed way to fail. You have to tailor the process.
Okay, what about the more practical side of things?
A huge practical factor that gets overlooked all the time is review the work product in small chunks. This just respects the limits of human concentration. For a big document, the review leader needs to break it up into sections during the initiation phase. This keeps reviewers focused and thorough, and it ensures quality across the whole document, no matter how big it is.
And what about the organization itself? What does it need to provide for this to work?
The human and infrastructure elements are crucial. You must provide adequate time for participants to prepare. If reviewers are rushing their individual assessment 5 minutes before the meeting, the quality of the findings will be terrible.
And that's where management has to buy in.
Yes, management support is non-negotiable. Reviews have to be seen as a valuable, required activity, not some optional overhead you can just skip when the deadline gets tight.
So it has to become part of the culture.
It has to. Making reviews part of the organizational culture, seeing them as a chance to learn and improve the process, is absolutely essential. It has to be seen as an opportunity for everyone to own quality together. And you also need to provide adequate training, especially for moderators and review leaders, so they know how to do their jobs effectively and objectively.
Okay, and finally, once the review is done, the output isn't just a fixed document. It's also information. What do you do with that information?
That's the last crucial success factor. You have to provide feedback from the reviews to both stakeholders and authors. This feedback loop lets them improve the product right away, but it also helps them refine their future work. The analysis of the anomalies you find, the types of errors, how often they occur, where they occur, that's vital data for continuous improvement.
For example,
For example, if you find that 80% of your defects are consistently in the system integration section of your design documents, that's a huge signal. It tells you that the team needs better training or a more detailed checklist for that specific area. This kind of data-driven improvement elevates the entire organization.
this has been such an insightful look into the mechanics of finding defects where they cost the least to fix long before the code ever runs.
Right.
Static testing, whether it's an automated tool checking code flow or a rigorous human-led review checking a blueprint, is really the intellectual activity of quality control.
It is.
And it just dramatically reduces risk and cost by forcing us to catch those flaws in documentation and design logic right at the start.
And the key takeaway for you listening isn't just that you should be doing static testing, but how you should approach it with structure, with purpose. You have to use the right tools, leveraging automation for efficiency, and you have to select the right structured process.
From the informal walkthrough for building consensus.
All the way up to a rigorous inspection for your most critical, high-risk work. And by making sure you have clear traceability, from the requirements to the user stories to the acceptance criteria, static testing ties everything back to the business goals. It ensures the team is building the right thing, correctly and efficiently.
That's a perfect summary. Now, for everyone absorbing this, we want to leave you with one final provocative thought, something that builds on this whole idea of proactive quality leadership. You now understand that testing is not just about execution. So if static testing finds defects so much earlier and so much cheaper, think about this. How might embracing the review leader role for critical non-code work products, things like architecture documents, high-level risk assessments, or even regulatory compliance summaries, how might that transform your career trajectory?
That's a powerful question.
By becoming the person who shepherds the quality of that foundational documentation, you shift your focus from finding failures to preventing them entirely. And that makes you indispensable long before the first line of code is even run. Something to think about as you contemplate your next move in quality assurance.
Thanks for diving in with us.
See you on the next deep.